Hello everybody. Welcome to NEPIRC's version of Industry 4.0. My name is Brian Medeyevich. I'm going to walk you through a quick version of everything that's going on out in our wonderful manufacturing industry with technology. What you can expect from this presentation, you're going to gain awareness of 9 technologies grouped into 3 sets based on a theme. What is it? How and why is it used? How might it apply to my business? And through a variety of methods with PowerPoint videos and open discussion, which we can use a chat session towards the end or throughout, however they come up. What is Industry 4.0? Where did it all start? First off, the major part is industry revolution based on the introduction of mechanical production equipment. Around 1784, the first mechanical loom was created, and that would be Industry 1.0. However, if you look, the printing press was actually invented in 1440, but that's really about all the technology we got out of the 1400s, I guess you could say. So 2.0 is the second industrial revolution based on mass production achieved by division of labor concepts. So basically we had a first conveyor system in a butcher shop, slaughterhouse, around 1870. Third industrial revolution is when we started getting PLCs, programming. A lot of stuff you see out there runs off programs such as roller coasters. I don't know if you know, but modern roller coasters runs because of a PLC. And it's a programmable logic controller. Tells you what's safe, if the next ride can go, and what needs to happen to run the whole operation. Our fourth industrial revolution, Industry 4.0, is where we're at today. That's all the fancy stuff we see everywhere, from cobots to laptops, cell phones, integrated systems, ERP systems that talk together. We're going to touch on most of that today. We're going to break it up into 3 quick sections here: robotics, additive manufacturing, the cloud, cybersecurity, big data analytics, and simulation. Horizontal and vertical software integration. It sounds like a big mouthful, but it really is not. This is the software or a combination of other softwares that supports and links every aspect of a business's daily operations. A lot of companies use these. You may not even be aware of it. The hospitals, manufacturing facilities, schools. You're capturing everything from the customer's demands, product specifications, to shipping, executing the work, verifying the work, customer replies, the whole works. What are some of the benefits of an ERP type system or horizontal software? Productivity improvement, single source of data. Productivity improvement would be, instead of running around looking for data, you have it everywhere you can get it. Most people now, I can pull up my ERP system on my cell phone. You can get information 24/7 all the time. The other benefits, inputs of other technologies. You can run simulations. You can see what it would take your company to do to make a product without actually having to make the product. The other issue about implementing big ERP systems is it can fail. There are many examples, and I believe I touched on this presentation on one example of the U.S. Navy spending $1 billion on a failed system that didn't work. That's because they had a lack of clear objectives. It wasn't the SAP company that came in, it was because the Navy didn't have objectives clear. So you waste a lot of money doing that. Believing that software will solve all your problems could also be a big failure. You can have someone say, oh, software's in there, but if you don't put the proper data in there, it's not going to work properly. Potential business applications. You could have salespeople working on a CRM system, customer relationship management. Estimating and quoting can be done in seconds. I'm currently working with a company now. It takes about 60 seconds to quote an order out. And you send it electronically through email, and they have it right away. That checks your whole system, lets you know if you have the parts in a house, the bill of materials to make the product and everything. Inventory management. If you know or you may think you're low on a product, you can pull out your cell phone, pull out your laptop, and check instantly to see if the product is in-house. Supply chain management, business intelligence, and report writing. Gone are the days where you have to sit down and enter all this data once a month. It does it automatically. You can see here are some of our examples that are out in the industry. Salesforce is one we use at NEPIRC. Infor, SAP, MRP Easy is a smaller one for 10 to 200 employees, Oracle. You've seen all these advertisements out there. It's a huge billion-dollar industry to make your companies better. How might it apply? It could be a small team that could use this material to make your team better. What can it do? Like I said, the inventory, the number of data sources in your organization. Why? Numerous data sources often lead to conflicting information. You go into a hospital and they say, I need my medical records. Well, I have to go to this system. I need to check my appointments. Well, I have to go to this system. When you implement a large, not even a large, a regular system for horizontal and vertical software, you have a one-stop location where you can go in and see all of the data. And our company, Salesforce, is one of them. Data sources of inventory, how might it help you? What's next? Is there an opportunity for standardization? You will find out that many times with your ERP systems, there's 7 different departments doing things different ways. You find out the best one that works with this system, and all of a sudden everybody else is doing things the same. That often is true when it comes to different organizations. You can have 7 divisions all across the United States, and they're all doing things different. You get them on one cloud, one envelope of software, and everything becomes the same. You can transfer it to another place and know how to do it, how to do the jobs. This is a really fun one I like. Big Data Analytics, Semantic WinCC. This, what you're seeing right here, is a production environment, a process support team. These gentlemen are watching live. You can see in this nice little image over here, this is actually a machine moving in live time for these guys here, and they can see what's going on. The guys are having a product quality issue. They can call it up and see, all right, we need to make a change. Change the speed, change the heats, change the pressures of that particular industry. He calls it on the radio, and they can see exactly how affected it. There's no longer waiting 3-4 days for the product to come down to inspect it and check it out and make sure everything's okay. You can see it live trending. This particular one is semantics. Semantic WinCC. Very good system, live trending. Again, how might it apply? It's going to affect all employees. It's going to increase productivity. Everyone's going to be able to get things done quicker. There's no longer waiting for huge windows of opportunities to inspect things. You can see it immediately. You can learn how to ask the right questions, build and share knowledge, and make decisions. Immediately, if someone doesn't know what they're doing, they can look into this system, see how the change affected the product. To help you with planning, vision, communications, identifying the current state. Questions get answered quickly. You can go out there and check what's going on. It also helps you measure your improvement cycles. You don't need to worry about long reports, long follow-ups. You can see it immediately. What's next with these types of systems? What questions your organization constantly need answered? Someone comes and says, I need to know the quality of this product. I need to know the size of this product. You can turn into the ERP system that has automatic data integration and pull all the information down. Again, opportunities for standardization. Does your organization have data strategy to chart the course of your desired future state? All these ERP type systems and these online systems can export all this information. You have a quality department who wants to look at something, you have an engineering department who wants to look at something else, and you can all access it all through the same system. Simulation. This is a really interesting way of doing improvements in your facility. This example you could see right here in this video. We have a bike shop. They want to add a second line. Well, they want to know how it's going to affect their production. Instead of going out there with one of our engineers, they can simply simulate it on a computer. The same engineer doesn't have to go out on the floor with a tape measure and start buying equipment. He could have this data built in, and you could see how it's going to change and make your investment worthwhile. I have a better video on here. Assembly line simulation. So this ability to test and change and see if the anticipated results occur with minimal disruption. What does that mean? That means you can show your investors, you can show your board, you can show your president of the company, what would it take? Now, this is arena simulation software. It's a really fun one. It's a lot of data entry at first, but once you get it going, you can see your entire assembly line. I know what the outputs are. I know what's going to happen. And you can also throw some kinks in there. Say your production manager says, well, that's all fine and dandy if things are running good, but what happens if an area breaks down? Well, in the software, you just break it. You stop that conveyor, you stop that motor. It gives you live data. That's the type of information you could send out and give to your investors immediately, instead of knocking down walls and realizing this didn't work and now you spent a couple $1 million on it. Simulation is a way of combining data with managers' unique knowledge of the business and offering results and superior outcomes to either method individually. What that means is don't do it on your own. Don't just bring the engineer out to type it in. Bring the production guys out on the floor or into the office to show you what can go wrong and what can actually be better before you actually spend any money. Although the software may be expensive, it's a lot more expensive than knocking down the walls and putting in new equipment you're not going to use. Again, it'll help small teams. It'll help document single process flows and capture relevant measurements. Quantitative baseline, learning how reality differs from supposed to be thinking. This simulation software isn't quite reality, but it's a lot quicker and a lot better than knocking down walls. What's next? What are you surprised at how reality differs from what you thought it was going to happen? That's the biggest thing there. How many times if you're in production environment, you've seen engineers, you see drawings, people are throwing stuff up, saying this is what we're going to do, and then you have the other guys going, it's not going to work. It's not going to work. Simulation software will cut to the chase. It'll get you there, show you how it can be done, and potential improvements could be done before you actually install it. A lot of places will install equipment in 2-3 years. They say, well, the way we should have done it was this. With the simulation software, you could just chase the ideas around and got it done before you spent money. We're going to move on to some fun information. This is where I think a lot of questions might come from. Robots and cobots, augmented reality, and additive manufacturing. And we have some really good examples in here from some of our clients. This one on the bottom left here is the one you've all seen in movies growing up, where there's robots making things, they're making cars and whatnot. You can see here in this whole area, it's all fenced in. This is not a really safe environment for human beings. A robot is a machine that's capable of sensing its environment. It'll look around, it'll see if the parts are there, it will make sure that no one's inside there. If you get a human inside here, the machines will hopefully stop and not hurt you. They are all programmed. Every single little step is programmed by them. So that's a robot. We've seen them around. We've seen them in movies. Maybe you've seen them in your manufacturing environment, often locked behind cages, you can't get to them. Cobots are the fun new way of working. Collaborative robots are complex machines which work hand in hand with human beings in a shared work process. They support and relieve the human operator. What you're going to see is a task no one wants to do, no matter where they're at. No one wants to take this wood and complete there and stack there. That looks like there we've got 1, 2, 3, 4 cobots in that spot. I'm sure maybe an operator brought this pallet of wood over there and he's setting it down, and with sensors, this robot's figuring out where to put things. This is also a safety issue. This is going to relieve everyone from having to do repetitive tasks. This isn't taking away someone's job. I do have some information on that. Let's see if we can get this to play. This is true story. You can go out and Google it and read up more of it. The company's still open.
Scott Fetzer Electrical Group manufactures a wide range of electrical motors and components in a constantly changing production environment. The company is now realizing a vision of having rolling robot colleagues help increase productivity and improve worker safety.
When I was brought into SFEG early last year, my goal or my task was to find ways to automate our factory, ways to make us more competitive on the global scale, ways to make it more advantage of the machinery that we had. One of our biggest challenges is we're a high mix, low volume producer. For most of our lines, they don't run every day. So trying to find a way to put robots on the lines in the traditional sense was a very big challenge. So we came up with the idea to do some sort of mobile force, but the challenge is how do you do that with all the safety enclosures? I came across this idea of a collaborative robot, something that could work with humans that you didn't have to be afraid of being around. When our workers come in the morning, their task is no longer to go do some monotonous task. It's to go take the robot and deploy it to whatever job it needs to do that day. And that robot's going to move all around our sheet metal department while it does that. The only way we were ever going to accomplish that was with a collaborative robot. When we looked in the marketplace, we only saw a couple of offerings. And to be honest, the UR was the only robot that we saw that we thought could do the job. It's got the speed and precision of a standard industrial robot with the ability to work around it with humans. We're trying to look for tasks that are either very monotonous, that are labor intensive, or potentially hazardous to do. And one of the tasks that we've automated is epoxy filling circuit boards for part of our transformer line. So that robot is actually part of our mobile fleet. So at the end of the day, we move it out, and then first thing in the morning when we set the epoxy machine back up, we move the robot back in, drop a couple of pins in the floor, and off to work it goes again with no more intervention from the humans.
What we've seen with implementing the universal robots is about a 20% increase in productivity on the lines which we put in the robots as a result of having a pace setter with the universal robots working hand in hand with our people. We've seen the ability to get much more competitive when we go out and look for new business, and we can compete with anybody. We're bringing back business that used to be in China or that we used to source in China. We've been able to reallocate some of our employees to other areas where we've seen growth in our business. We're seeing about a one-to-one movement of people from where we put in a robot to allow us to move one person to another area of the business.
When the robots first came out on the floor, employees were very anxious and a little nervous about it. But now that they're out there on the floor, they act like they can't live without them. They are constantly asking, can we put a robot in this position? Could we maybe put a robot in this position? You know, there's a lot of people who are trying to figure out where we could put our next robot to help our process. We have Thelma and Louise, who were, at first everyone was scared of Thelma and Louise, but she's actually a part of the family on the floor now. That's how they got their name. We were expecting it to go off the cliff, and she saved us, both of them actually. The process of the robots were actually a lot simpler than I had expected them to be. If you can work a smartphone, you can pretty much work these robots.
It was really easy to learn, and it went much smoother than I anticipated. I was a little antsy using the new technology with the collaborative, but it was really easy to use. I would say it took a third to half of the implementation time out of it based on previous experiences I've had. You can actually read through Modbus TCP connections, robot status. We can pass information using the Ethernet socket connection to other software packages to collect data. It opens up a lot of doors to do a lot of things that we're just now beginning to look at.
We've got 2 robots working with humans. The first robot's actually cutting wires off of the motor field. That's a potential carpal tunnel syndrome application. I mean, you're cutting about 16,000 wires a day by hand. And so we thought that was a great place to put a robot, you know, let them potentially get carpal tunnel. And what really made this cell happen was the collaborative nature of the robots. Some of the future applications we have is we're looking at everything that we're designing now new and making sure that we can assemble it with a robot. So we're looking at all of our design work and saying, if we can't put that together with a robot, we've got to go back to the drawing board and try again.
So, that video we just watched, the reason I like that video so much is it gives you an idea of what the operators are saying. They're getting in there and they're afraid you're bringing a robot in, it's going to take my job away from me. Back to the previous slide, what I said was we're doing jobs you don't want to do. These are jobs that are possibly unsafe, not ergonomic, not fun. These are making you do your job more productive. So increasing safety, ergonomics, increasing throughput, employees free to work and move onto more interesting tasks. If you take the tedious task off an employee who's sitting there doing this every single day, and he no longer has to do that, he's going to start looking around going, all right, that's my job, but maybe now I'll start looking at the quality down the line. He's going to start improving quality. He'll start coming up with more ideas. He's going to be more interactive, raising his hand and saying, you know, maybe we could do something over here instead of that tedious job. And there's a lot to say about that. 9 out of 10 employees would take a pay cut and work in order to do more meaningful work. I totally agree with that. Tedious jobs, driving a forklift back and forth, those type of things. Once we get these cobots and robots in place, I think it's really going to help the entire industry. Here is a good example of this. These are actually 2 of NEPIRC's clients, a local stainless steel manufacturer and a local robot manufacturer. Not saying they teamed up, we just happened to know both of them. This job was a very unsafe position. What you see at the end of this stainless steel tubing is a very sharp edge. And on the ground over here was an operator who had to stand there and load these tubes into this straightener one at a time. He'd grab the tube, flip it up, put it in there. Grab a tube, flip it up, and put it in there. These tubes, they don't look long, but they're actually 50 feet long, about inch, I'd say, round. And it's very tedious. This was a union shop. They did not want a robot to come in. They fought this like crazy, to the point where the operator ended up still standing there when the robot was put in there, go, nope, this is my job, you're not taking it away. Well, that operator ended up walking to the other end of the machine and watching the process and improving quality. He still has a job. The cobot or robot is in there, and it's fantastic. It was expensive. This was a big system, but it totally increased safety. What can we do with it? It's going to help all employees. It's going to identify daily tasks that are simple and repetitive as candidates for automation. Once you get one of those machines in there, you're going to realize we could use it in other places. Opportunities for ergonomic improvements, allocating employees for more meaningful and engaging tasks. It's going to help identify examples of automation to be shared within the workforce and in other divisions. What happened here in that particular one with the yellow robot, once that was put in, everyone wanted in other divisions. Can I get that? Can I get that? Even though everyone was so against it in the beginning. They're going to look for tasks in their area that are similar in complexity, tightening screws, moving boxes. Can this be done by a machine, yet I can still have my job? Determine and publicize prioritization criteria. And that's that for that. So robots and cobots. A lot of people were surprised at how little they cost. There are some cobots I've seen are only around $40,000 for the machine itself. And yes, there's going to be upkeep and all that, but it's a lot more than health insurance and issues for the workforce. Could you identify one or two processes that might be a good fit for your automation? Watching this video, you may pause and say, you know, maybe we can get something like that on the production line. Maybe we can get something here. There's a lot of, I would like to call early phases of cobots, polywrap pallet machines. That used to be someone would run around a pallet with a big roll. Now it's done on the spinning machine. I don't think anybody lost a job for that. And you got to see if a robot or a cobot is better suited for your situation. Cobots have limited capacity. They can only lift so much. If a robot, if you climb into that cage and the robot comes near you, it's going to hit you. It's going to hurt you. It's going to possibly kill you. Cobots have sensors in there and they have servo motors. They will sense if it comes near you and it'll stop. I cut it short, but at the end of that video, there was a gentleman standing in front of him and they let it hit him and it just faulted out and stopped. It just bumped into him. That's a huge factor in the difference between cobots and robots. Additive manufacturing, this is a really fun topic. What is it? What is it doing? Well, additive manufacturing is actually what it is, what you're saying, adding. You're adding material to it. You're not subtracting, you're not taking it away. A group of technologies that create products through the addition of materials, layer by layer, rather than subtraction, mills and lathes. If you take a big chunk of steel and you make a small part, you've got to mill it all away, you've got to drill it all away, and you've got scrap on the floor. This is different. Additive manufacturing is a new way. You know, it starts off with plastics and metals. There's many examples of it here. You can see right here, this is heated steel, almost like a plasma cutter, that's adding up material. No slag, no mess, no scrap. Nothing has to get recycled. It's all done right there. Same thing here. This is, I believe this is aluminum one, and that's a fiber one. Fiber steel, I believe it's called. 3D printing. This is a really funny thing that if you Google it and look up on it, it's pretty interesting. People think 3D printing, why is it taking off? Why is it taking off? Why is everyone talking about it? Why is everybody doing anything about it? Well, 3D printing was invented in 1981 but not fully patented. Then a French team was granted the patent with their design in 1986 but lacked funding to fulfill the design. Not until the University of Bath in England created an open source free program to create economic savings did it grow so fast. You can also keep looking where the patent ran out, which is why everyone's using it now. If you have a patent on something, you're the only one who can use it. Well, once it got out of lock and key and everyone can do it, everyone started thinking about it. How can we make things better? There's tons of examples where you can ship material, you know, sort of like Star Trek. is that copyrighted? Can I say that? Star Trek, where you have an idea and the engineering firm is in London, but you're somewhere else and you send it to them and you create it. Here's another. Let me see.
Use objects from tools and toys to clothing and even body parts. 3D printing is part of a process known as additive manufacturing, where an object is created by adding material layer by layer. Additive manufacturing allows designers to create complex parts for machines, airplanes, and cars at a fraction of the cost and time of standard means like forging, molding, and sculpting. Now, smaller, consumer-friendly 3D printers are bringing additive manufacturing to homes and businesses. The first step in 3D printing is to create a blueprint of the object you want to print. You can use modeling software like Blender to create your own designs, or you can visit websites like Thingiverse or Shapeways to find objects other users have 3D modeled. Once you have a finished design, it's time to send it to the printer. Some printers, like the MakerBot Replicator 2, have renewable bioplastic spooled in the back of the device, almost like a string. When the printer receives the data, it pulls the material through a tube, melts it, and deposits it to the plate where it instantly cools. As you can see, the 3D object is created through layering, where the printer will add one layer of the object at a time until you have a fully formed structure. The most common material used in 3D printing is plastic, but the use of some other materials allow for the creation of some pretty amazing products beyond simple tools and toys. 3D printing food is becoming very popular, and additive manufacturing has allowed for the creation of some pretty intricate treats. In the medical world, doctors are testing biomaterials for regenerative medicine. By using a patient's cells, doctors could 3D print small body parts like ears and noses. Some surgeons have even tested 3D printed organs for transplants. Recently, giant 3D printers in China printed 10 houses in just one day and at a cost of less than $5,000 per house, proving just how cost and time-efficient 3D printing can be. For more on 3D printing, check out Mashable's latest coverage. And
so, 3D printing, it's pretty neat. You can see the industries that are changing from it. I like the medical aspect of it, not just creating parts and all that, but possibly skin. They're saying instead of grafting your skin, you could take your cells from another part in your body and create skin. Additive manufacturing can also improve part performance. That's going to be our next slide. If you're a Ford fan, which I'm not, if you're a Ford fan, you can see a really cool, unique intake manifold they had on here. It's rapid, often inexpensive prototypes that are made with 3D printing, on-demand, low-volume, end-use parts and tools, handles complex traditional designs that machines cannot. Believe it or not, there are some things, and you'll see in the manifold video next, where you can't quite create unless you weld and cut and drill and then do it all over again just to make it. And in the medical and biological type stuff. And there's also, NASA's using 3D printers, beam me up type stuff.
It was the pickup he learned to drive in, do his first burnout in, and got to races in. So when Ken Block was looking for the star of his next Gymkhana video, he found a 1977 Ford F-150 pickup that was perfect. But there was just one problem. The missing piece of the puzzle was a bespoke intake manifold needed to supply sufficient air from the turbochargers to the cylinders. This large part for the US-built Huni truck required a complex web-like structure and could only be built using Ford's cutting-edge 3D printing technology in Germany. 3D printing, or additive manufacturing, is a toolless production method that offers design flexibility to help reduce weight and improve performance. Ford engineers worked together with experts from the University of Aachen to develop the part. Based on computer-aided design, the intake manifold was built up layer by layer over 5 days. The inner structures required huge amounts of computing power to execute. It's the largest 3D printed metal car part ever made and implemented into a running vehicle.
I think my favorite part is the intake manifold that Ford Performance developed for us, because it's 3D printed. It is designed in such a way that you could not make that from a cast or from a mill. I just think Ford Performance did an exceptional job.
With over a century of motorsport racing experience, Ford Performance is proud to be directly involved with the development of Gymkhana 10 star, the Huni truck.
So I just did a commercial for Ford, apparently, but it's a really good example of what you can do if you put your mind to it. You know, often in manufacturing, people say, "I have an idea. I have this thing." Well, okay, how do we make it? And that's the problem. You can't always make it. With newer, improving technology, we can start doing this stuff. Again, we're back to who can help, who can benefit from this. Small teams identify opportunities for improving current processes or creating new revenue streams. I can never make that product before, but now I can. That's a potentially new revenue stream. Reduce internal process costs, capture share of an emerging market. You know, if you can make a product no one else can because you have 3D printing, be it metal or plastic, you're going to benefit from it. Can you save money by proofing a design using cheaper materials? Yes, you can. There are different divisions all around the world of the same company. And one division in Canada says, hey, you know, I think we can make this product. Here's the design. And they could send it to the same division over in, you know, Japan or somewhere, and they can make the product go, yeah, you're right. It's gonna work. Let's put it into production. Instead of wasting a lot of time, a lot of money doing that. You have excess engineering capacity that you could offer to customers alone in conjunction with additive manufacturing. That is an important thing because you have a customer that says, I want to make this product, I'm not sure if we can make it. If you are good at 3D printing, if you are trained on it, you can make the product, send it to them, and then teach them how to use it, teach them how to become their own supplier of materials. You don't necessarily have to have a 3D printer, you just have the engineer who can make the files. Could you offer additive manufacturing as a service? Exactly what I just said. Customers send you a drawing, you print and ship it. You're not actually doing anything. You're making the design, you're spending all your time in front of the computer, and you're sending the file to the 3D printing service, or the customer actually has one. And it's future, it's here, it's Star Trek here. Thinking inside and outside of the box. Did you answer yes to any of these questions? Think about your business. Think about your manufacturer. Can we use this here? Is it a lot of money up front? It's not as much as you would think. Do you have resources in-house to research and implement this technology? I bet you do. I bet you do, and you don't even know it. Do you have relationships with any companies who have experience with the technology? Like NEPIRC. We are a company that has our own 3D printer. You can work with an organization that has one. Augmented reality, it's getting everywhere. It's not just for children anymore. It's not just for Pokemon games. You can research many aspects of it. In this particular instance here on the left-hand side, this gentleman, a shift supervisor, of course I believe this is mostly fictional at this point, but he shows up to a job site. That truck over there has got sensors all on it. If you think about it, your car has sensors on it already. It's got sensors everywhere. It tells you if your windshield wiper is low, your door is open. But it also checks all other stuff, your temperatures, your speed, your hydraulic fluid. In this case, it's a rock crusher type machines. You can check the capacity. So this gentleman puts on augmented reality glasses and he's just looking at a machine. Is it really that far-fetched? I don't think so. It's just your computer that's already in the car, the vehicle, sending the information to somewhere else. You're sharing it. You can glance at that vehicle, you can glance at that machine and see exactly where it's at, what its capacities are, where we're going. Here's one people didn't realize was augmented reality. Back in the 1990s, one of the first public applications of augmented reality occurred in the late 1990s, the first downline display during NFL games. That is augmented reality. What they do is they use the position of the cameras, similar to the cameras that are recording me right now. It tells me the angles that it's at, and they have the players around the field, and they already went out and measured with lasers the actual grass, and they know where it's at. They move the football up to the first line or down line. They put a yellow line on the ground. That's augmented reality. It's not really there. So they tried it in hockey, but the hockey fans didn't like it. This example you have up here, right there, that Chevy and MLB ad is not there. That's a green wall. There are sometimes you'll catch it once in a while on sports shows where you'll see a little green wall. That's not there. If you remember, if you've ever been to any major game, there's a huge ad. Sometimes they roll, sometimes they change. They're going away from that. It's green wall technology everywhere, green screen, and it's augmented reality. You can see that pitcher's head there is perfectly hidden or around the ad. It's augmented reality showing you how to do things that normally we cannot do. You don't have to change out the ads. Last minute, someone says Chevy's pulled their ad, they're not running it. Ford's going to be up. You can put it on there. Again, how is it going to help our business? What can we do with it? You got to think about it. Perhaps the same engineers who are working on 3D printing can work on augmented reality. He can go out and take pictures of the facility and put some simulation type things up in there where you could see this is how it would look. Put some goggles on, bring your investors around and go, this is how the new highway is going to look. This is how the new building is going to look. A new intersection. Static augmented reality, what's next? Based on your experience with static augmented reality, are there processes that might make it worth investing in true augmented reality? Are there? Can you come up with ideas and ways to make it work in your warehouse? You can have people put goggles on. I did have a video in here, but I'm not sure if I left it there or not. No, I did not. I took it out. There's an issue where you have an operator is on a forklift. Same exact thing we saw before, where the site supervisor shows up with glasses and you can see the entire production floor. Machines. Imagine if you had your forklift with the same glasses on, and he's told to pick aisle A4, and it's in the warehouse down there. He's got these glasses on and it's highlighted. You just drive right to it and you pick it up. You can say the same thing for your forklift. If your forklift breaks down, you can just look at it. It's using the computer that's already in there and it's sending the information to your glasses. Connecting and protecting your assistants. So we're going to talk about cyber security. If you've been following Manufacturing Day today, Manufacturing 2020, we did discuss a little bit about cybersecurity, but we didn't really touch much on industry Internet of Things and the cloud. This is an area that's pretty fun, not as fun as the augmented reality stuff. Let me get that play.
Connection via the internet of computing devices embedded in everyday objects, which can send and receive data and generate all kinds of smart information. The Industrial Internet of Things, or the IIoT, is the extension of the Internet of Things into the industrial world and its processes. Historically, it has been difficult or even impossible for business leaders and manufacturers to correct problems as a process unfolds. Predictive maintenance is seldom possible, nor is asset tracking or dynamic routing or scheduling. This hampers efficiency and leads to costly, time-consuming investigations that cause downtime and can damage or destroy customer relations. The Industrial Revolution set down a business model that has scarcely altered in 2 centuries. This has led to a correspondingly reactive attitude to problems, since technology has not previously allowed business leaders to make course corrections during a process, or to allow for proper asset tracking, condition-based monitoring, or even a proactive relationship with customers or employees. The IIoT represents a massive paradigm change in the way industry functions. Instead of forcing industry leaders to observe a finished process or product and then walk backwards in hopes of finding where problems first began, the IIoT uses embedded sensors that monitor every phase of business activity as it occurs. This expedites data flow and analysis, which leads to fast insights, which in turn speeds up decision-making and corrective action. It also allows for predictive rather than reactive maintenance, asset tracking, dynamic routing and scheduling, and asset and process optimization. The IIoT also facilitates communication with customers to promotions, offers, and new product rollouts, and guides them via mobile device wayfinding. Our technological landscape is changing. Advanced Manufacturing Technology, AMT, is an industrial evolution that will help companies prioritize long-term business goals over low-risk short-term returns and succeed in today's smart manufacturing environment. Reach out to Northeastern Pennsylvania Industrial Resource Center for expert knowledge of advanced manufacturing technologies and assistance with technology implementation.
So if you're familiar with the industrial environment and you work in this field, you know that when machines break down, it causes a lot of downtime. Well, traditionally, you need preventative maintenance, predictive preventative maintenance, to know when that machine is going to break down. It's really hard to do that because you need downtime. You need time to get in there. You need somebody to go in there and do PMs and cleaning, grease, and check sensors and all that. So it doesn't really happen all the time. And then all of a sudden you break down and there's 4 guys saying, yeah, I knew that was going to break. Well, imagine if the machines were talking to each other. And this is what's happening now. You have sensors on these motors that say it's going to overheat. You have a bearing that after so many hours of running, it needs to be replaced. What if you were measuring that? Just like the timer on a forklift when you climb in it says it's been running for 100 hours, you need to check the hours on all the equipment. They start talking to each other. The equipment is going to tell you that, hey, this is overdue to be fixed, and you're going to prevent downtime. Say it's a facility you only run 5 days a week. Do the repairs possibly on the weekend, or plan around existing downtime. And this is because the machines are talking to each other. Yes, it sounds sci-fi. It sounds like we're going to be taken over by machines. But you think about it, it's going to make your life easier if we're gauging everything that's happening with these machines. So the industrial Internet of Things, which is what we're calling this, informs predictive maintenance, adjusts additional sources of data, asset tracking, improved safety. If you think about it, if you're tracking an overhead equipment, yes, you have your monthly inspections. Yes, you have safety items that need to be checked, like cables and slings. But what if there's a sensor up on that crane above you that has an overheat sensor, and it's sending the information down to you, and you're like, oh, we got a problem above us. It's not going to break down. It's not going to fall. It's not going to hurt you. Industrial Internet of Things may already be in your home. I know in my house I have 7 Alexas and I have one in my car. I'm not always a fan of them, but they're very, very handy. I know my phone right here. I could reach out and ask it to turn my lights on and off in my house, open my garage door, turn my radio on, those type of things. You can reduce frustration, improve standardization, where it can all see the same exact files. You don't have multiple divisions creating different files. Let's see here. Did you answer yes to this? I'm sure you did, because I would bet at this point most of your manufacturing facilities already have cloud working. They already have servers up and working. Here's a really good example of a cloud-based system. Stormboard. If you see these photos in the background, that's the traditional way that we think. This is the way we troubleshoot. We come up with ideas, we write them down on the wall, we have whiteboards. There's a lot of offices now that will paint the wall white, and you can just write on the wall. It's a whiteboard right on the wall. And, our traditional old school notes and all that. Stormboard is a really good system. I've been using it for probably about 9 months to a year. It's basically a digital whiteboard. You're throwing sticky notes up there, and you can collaborate with anybody. You can give access to other users so they can jump in there and see your thought process. This is great for troubleshooting. And they have all kinds of different price ranges, $100 a year to $10 a month to, even less, and if you get into corporate accounts and stuff like that. These are all cloud-based systems. There's tons of different ones out there. I can't think of the other one right now. Whiteboard one from Microsoft has one. This is information that's all saved in the cloud. You don't need to go back to the office anymore. You can just grab it. Tons of cloud-based systems out here for sharing photos, content calendars. Airtable is one of the good systems too. This is also the cloud. This is something people don't think about. Netflix is the cloud. You don't need a DVD anymore. You just log in from any device and you can get it. Skype, you can use, Skype's going away with Microsoft Teams, which is usually where we're running things like this on. This are all social media, Office 365, Pinterest, your Alexa and all that. This is getting all the information, Google from the cloud. This is all out there. It's not saved in one central location. Our last one we have here is cybersecurity. I know we touched on cybersecurity earlier in the day, but it is very important to protect your systems. You come into work, don't jam a USB into your computer that you don't know what's on the information. We have to watch out what we're doing. You don't want anybody to destroy your information. There's some examples I have here. I'm not going to pronounce that name, but it's a Russian name. Excuse me. There are 63 cyber criminal groups on FBI's most wanted list. One, Evanchel Magachevich, developed malware to access bank accounts and stole over $100 million. This is current. He's still missing. He's out there. He gets into your computer, he locks up your computer, and you can't get any more information out of it. And then you have to pay someone to get it. Excuse me. How might it apply to my business? Everybody. Cybersecurity is important because we're running everything on computers. Passwords. Save all your passwords. Change your passwords regularly. Criminals are smart. They often look for other information. And there's tons of online resources, but stick with what you know and talk to your IT department. Excuse me. I bet you were thinking this one here. Are there any security issues that you need to resolve? I bet you can think about some at your company. I know I can at mine. There are some issues that there are ways around it. Technology is constantly changing. You can't stick with the old software. You can't stick with the old malware protection. The efforts have to be eliminated. And you have to think about it in your workplace. And questions. We're on to questions here. Hopefully Chelsea has some good ones.
Yes. The first question is, are there use cases where a 3D printed part would be viable to use in production?
Yes. I can think of one specific company that has a division in Sweden and one that has one here locally in the Scranton-Wilkes-Barre area. They had a product that was a die they used in extrusion process, and although at the time it was made of plastic, they came up with a new design and they wanted to see if it would work in production. So they sent the file, the other division prints it, now it's all across the ocean, it's done, it's quick, no shipping, and they tried it in production. They simulated it in production because the normal die is made out of metal. They simulated it in production, they're sure it was going to work, it tested out properly, and then they placed the order. So then it gets shipped over on the boats and whatnot. It saved a lot of time instead of spending all that shipping. Another question?
Yes. What safety concerns, if any, should a manufacturer be aware of while using collaborative robots?
Well, what safety concerns should anybody be aware of with collaborative robots, especially in manufacturing? There are some concerns that I've been thinking of. For example, I said before about servo motors. Servo motors will detect if there's a resistance put on it. So if it hits an operator, you can put sensors on it so if it senses an operator. But they're not very strong. They're only limited capabilities. However, I have seen cobots where they could have sharp objects on them. Say they have a drill, or not a drill, a screwdriver, and it turns. It could possibly poke someone. It's not going to stab them terribly, but yes, there are some small concerns with cobots. Nothing compared to actual robots. Any other questions? That is it. Thank you guys very much. Have a good day.